Good evening to everyone out there in the world. Welcome to today's talk. We're going to be talking about vector stores and embeddings. We've got Pujithar and Prashant today. They're going to be talking about that. Before they start, though, we have got a Q&A pod. If you have questions, please put them in the Q&A pod so we don't lose them inside of the chat. There's probably going to be a lot of people chatting in there because you guys are chatty Cathys. We also have Sandeep. See, there you go. There's a chat. We also have some links today. So probably a lot of the code that you're going to see here today is going to end up on our GitHub, the Adobe ColdFusion GitHub. I have a link to that. If you want to be part of our beta, where you could try this stuff out today, even during this, if you want, if you're crazy like that, you have the sign up for the beta there. And then eventually this is being recorded, will get pushed up to our Adobe ColdFusion YouTube. But enough from me. I'm going to go ahead and hand it over to Pujitha. Over to you.
Hi people, hope everyone are doing well. This is Pujita. Today I'm gonna be talking the part of this presentation about vector stores and embeddings. How do we deal with them through ColdFusion? So let's get started. And before we start how we deal with them through ColdFusion, I think we must know the what embeddings and vector stores mean, and I'm gonna explain the agenda of this presentation too. So in this presentation, we are gonna talk about what does exactly vector store and embedding models mean and how they are connected to LLM, how do we bring up a RAG upon it, and then the supported vendors in ColdFusion for vector stores and the embedding models and the typical workflow that we have, how your text gonna be, converted to embeddings, how are they gonna get stored in vector store, how are they gonna get used as a context for any question that you ask LLM to get a precise answer. And as a part of this presentation, we are also going to talk about the functionalities that we support for both vector store and embedding models. And we also will see how we can do a workflow with configuring embedding model along with vector store and without it. And also I'll walk you through the administrator page of vector stores, and we can um, come up with questions and answer session. So basically, the embeddings mean it's just a numerical presentation that of the text that you give to the embedding model. And the vector store comes into a picture where there are numerous embeds that you want to store at one place and have indexing metric type in a place. There the vector store comes into a picture. So together they make a brain of LLMs where you can give a peculiar context to the LLM in order to get a very precise answer. So here we also have an example where you just give a text, which is what is ColdFusion. The embedding model converts into a vector of whatever dimension you define, and then it gets stored in vector store, and then we can use it for a semantic search where you can have the score of how much match you want the answer to be to the question. Also, how many the top 3 4 answers if you want, even we can get that. And the supported providers, I have listed the supported providers of vector store in ColdFusion, which is Milvus, Qdrant, Pinecone, Chroma, and InMemory. So for to just get immediately started with vector store, the simple config that we have, you just have to call the vector store here. So you just have to use this vector store function. Immediately it comes up with the all mini latest embedding model that we have already shipping with the ColdFusion. and rest of the providers have their own best use cases. The Milvus is always known for the enterprise scale production, and the Qdrant is also have a best filtering and retry logic for the semantic search. And also the Pinecone is a cloud managed, it is auto managed by the cloud management itself, and you don't have to bother about the configs and upgrades for that particular vector store. And Chroma is a bit similar to in memory, but it's um, very lightweight, and it is very useful for small experiments of small projects that you have. And in memory is basically very useful for testing and development locally. And in case of embedding model providers, we are supporting OpenAI, Azure OpenAI, and Mistral and Olama. These are the vendors, and whatever embedding models are supported by these vendors, all we are supporting all of them. Here also I have mentioned the quick start config that you can just use this config, and you can bring up the embedding model over here. So these are few examples that I have mentioned. And moving on, so this is the main part we are going to focus in this presentation, which is a workflow of how your text is becoming vector, and how the vector is getting stored, and how eventually it is being used. So once you give a text to the embedding model, and every embedding model has their own dimensions. So the higher the dimension, the more the higher the dimension you have, the semantic search more peculiar to the answer that you want, you can get that. So through embedding model, we can get the vector, and the vector gets stored in vector store, and then from there we can carry on with the semantic search. And the supported functions in the vector store, there are multiple functions, which is the vector store where we bring up the client, and then there is a add function where you can add a single uh, text string. Also the add all, which bunch of text strings you can add at a time. And also when you are done adding, you can also search over the things that we have already embedded in the vector store to search. And we also can delete through the id of the vector, or also any filter that we can apply and delete it also through the delete collection. So and for now I'm just giving the reference of the functions that we are exposing for vector store and embedding model. Later when we move to demo, I will give you more clear examples so you can have a thorough understanding. Moving on, we have embedding model, which is a function that brings up a client with a provider and model name that you mentioned. Also the embed and embed all, which is again the same thing as a add and add all, where in the vector store, the vector, if you the provided vector will get added into the vector store, whereas here the embed just the embeds the given string, which is here the quick brown fox jumps over the lazy dog. Yeah, this sentence you can as well see here, like if this is the text that we are providing to the embedding model, we get this sort of uh, array of vector. So yeah, this embeds, later we can add it to the vector store. That's where this comes into the picture. And embed all is also same, as we can have a bunch of text strings and we can embed all together at a time. That's where it helps. And then now coming on to the main part, where the usage of vector store with and without embedding model configuration. So from here on, I will walk you through the demo so you will have a more context and clarity on this. Here I have just provided the examples if you just to take a look at firstly, and then we can move on to the demo. So here I have um, here I have configured the vector store, and then the embedding model here separately, and then we are first embedding the text, and then we are actually adding that embedding to the vector store that we have configured here. So this is how we proceed without embedding model config within the vector store. And if you observe here, the embedding model is already configured inside the vector store. So this is the difference. Here, if you want to add something into the vector store, when you don't configure embedding model, you have to first embed the text that is required for you in your case, and then you have to add that particular embed into the vector store. But in case of configuring embedding model already with the vector store, is just that you just have to pass the text that you want to embed along with the metadata, and then you can perform the semantic search with whatever filters that you have in mind. Excuse me. And then we have the search and metadata filter. So these are the filter operations currently we are supporting and looking at. And this is one of the example that we have. Like we are at least we are trying to find out autonomous invoice agent with at least minimum score of zero point 0.5 is 50% match to the text that we are seeking, which is autonomous invoice agent in this case. And top k is the top 10 strings that matches with this particular autonomous invoice agent will show up here. And we are applying a filter here, which is a product ColdFusion, and the year 2025 is basically in the ColdFusion of 2025 with the 50% match of anything which is related to autonomous invoice agent. The top 10 of them will show up as a result in this case. I hope I am clear here. And then we have a further advanced filter example where we have multiple category and we are using multiple filter options in greater than and then or. Yeah, so moving, you can combine all this, make permutations and combinations of this filter operations and use them as required in your case. Moving forward, we have delete operations. So this particular delete operation is we can delete the vector which is created with a particular ID. We can delete that particular vector with the ID that has been created. Also, we can delete a bulk of vectors that has been created with just a small filter, which where the required vectors which needs to be deleted come under that filter. You can apply the filter and delete them off all. And delete collection is the whole drop of the collection. So if you see here, so the docs is the collection name. If you do the vs dot delete collection vs dot delete collection, in this case the whole docs gets deleted and you won't be able to further revive it back. So this is a small example where uh, we are trying to delete a collection with ID. The vector gets deleted with whatever ID that we define. Also, the filter we apply and the vectors which come under this filter get deleted if we apply the filter and do the delete all function. Also, the delete collection, the whatever client we create, we pass a collection name as a parameter. So whenever you do the client dot delete collection, the collection gets dropped, which is deleted. So moving on, I wanted to show you the practical execution of how all this creation of collection, add all, embed all, how with and without embedding model, how do we uh, do a workflow that way, all this stuff. So let's go to that. So yeah, first let's for for now I'm trying everything with an example of Milvus provider. So let's start with it. Let's, as it is a with embedding model, let's try creating with embed model. So when we run this, so it says the vector store created with the embedding model. Let's go and check it out. So here it is. So here we got the embedding model with embed model collection, and let's try creating without embed model too. So just just a suggestion, or let's say a few points from my side. You can host the providers in a very different ways. I have hosted this particular thing on Docker, and I am running it through Atu. Atu is a platform where we can see what's happening in Milvus, whether the in databases of Milvus, which are stored in Milvus, and the vectors and the collections in the Milvus whole thing. But you can also host it on Zillus Cloud. Uh, yeah, you can also work it out that way. Pinecone is again the cloud based vector store. I have also hosted the Qdrant on Docker, but you can directly host it. Please do. For every function to work in ColdFusion, we must have the pre-configured vector stores already in place, so uh, so that the functions run smoothly. So as we now created the collection, so let's go. Let me just delete these so we don't have so many. Yeah. So now let's go add something with embedding model. Like if you see here, I have already configured the embedding model within the vector store itself. So let's go and try adding some of the strings. So yeah, if you see here, so I am providing an ID and also the text, also the metadata. And here, this is a function where which we use to create an ID. You can also provide the custom ID. You can also pass a string in that case. So if now the every add function will return the ID, so you can know how many um, vectors has been created. So if we go here within embedding model, see these have been created, which are in total 5. So we have added 5. Yeah, when we go with without embedding model, so first we have to embed the sentence or the string, whichever string that you pass, and then we have to add that particular embeddings in the embedding parameter and then add it through the vector store. So once we run this, we should be able to see some of the vectors in without embedding model config vector store. Yeah, we got them here. And now let's try to perform a search on this. So see there we have got three results here because the top case 3, let's change it to 2 and then try it. See, we got two results which are about score zero point 0.8 and zero point 0.7. Let's try making it zero point 0.9. All right, so we found 0 because we don't have uh, any text with that relative score of zero point 0.9. Let's go for zero point 0.8. So we only have one text which is similar to the query that we wanted to do for the vector database we already have. The same goes with the without embedding model, but we have to first, whatever text that we are providing here, as the vector store is already configured with embedding model as we have seen in the create collection tab, here the embed of the query isn't required. But for this vector client, we did not provide the embedding model, so we have to first embed the query that we are uh, embed the query that we want to do on the vector database, and then we have to provide that embeddings, and then you can apply the filter and get on with it. So here also it goes the same. So let's go further and try to delete. So here you can see we are trying to delete with the metadata filter, that is the category which is in ML. And if you see here, we are also trying to delete something with a last vector ID. So here we have removed the first one, and also we have remaining docs of 4. So let's try and see if there is. I think we have added something in the category AI. So if we further delete in the category I believe we must have 3 documents. So yeah, that how the delete function works. And also you can try this delete function where the functionality, the collection itself gets dropped. Let us see if it got dropped. Actually, yes, the width embedding model got dropped. So this is the functionality that we are exposing with vector store and embedding models. And I think most of you now would have a question: what if we have a lot of documents, and then we just have to inject, we just have to make embeddings out of the documents that we have? And how does add and add all helps with that? Add and add all helps mostly with let's say for very we have a database like a table database, and then we want to make embeddings out of it and then query it and then get the semantic search going. For that, you can directly use add and add all functions. In that cases, these functions come handy. And also you might also be having a doubt where uh, when we can already configure the embedding model within vector store, why do we have a different functionalities for that, where embedding model, embed and embed all functions are shown? So these embedding model, embed and embed all functions come handy where you have to try to have same embeddings across different providers. So that's where you just have to embed it once, and then you can use add and add all function to make it across providers, like the same embeddings, different vector stores. That's the case, it comes very handy. And it also um, makes you makes the cost of API very less. So that's also a best use case that we can bring out with the functions of embed and embed all. So further to this presentation, all must be having advancing to this vector store and embedding functions, where if you have documents you have to chunk it, and then you have to make a vector store, make a embeddings out of a document, and uh, we can't or add text all the time. And further advancing, you can also strategize the chunking, how how much chunk size and chunk overlap that you gonna need and stuff. So for further deep dive, um, my friend Prashant will take over from here to explain that advanced practice and then dive into the rag. Prashant, will you be able to take over?
Yep.
Thank you.
Okay. Thanks, Pujita. I'll share my screen. Is the screen visible?
Yeah.
All right. Good. Thanks, Pujita, for the vector store presentation. I'll be. Hi guys, I'm Prashant Dubey, and I work with Adobe in ColdFusion engineering team, and I'm the QA for testing the RAG feature, and I'll be giving a demo on the RAG features that we are offering. And so, just to give a overview of how the workflow will go, I'll just tell you. I have a slide here, deck of slides here with me. There I'll be showing you what are the configurations and what are the parts of our feature that are being offered. Then I have a demo application here that which I will be parallelly showing you how they work side by side. So here I have a code for that. I have some large number of documents which I will be using. Some documentation that I have created, some basic documents that I will be using for quick demo of RAG services. Then we have guardrail, and there is a lot of code here. So while giving the demo, going through this much code can be a little messy. So I have created these pages where there are just short snippets that I have taken out to just to show you how they are being used. So I'll quickly introduce you to the agenda of this presentation. So we'll be covering what exactly is RAG as a feature. Then there is simple RAG. One part is simple RAG in ColdFusion. Then what are the providers and vector stores that we are covering that Pujita has already covered. Just to give the overview of how that is linked to RAG and how that is being used. Then document, we'll be talking about document ingestion, the formats that are being supported that can be used with the RAG service. Then there is advanced RAG pipeline where we have a lot of options. Then there are guardrails, which is a part of advanced RAG itself. Then we have a document service, and then we'll go through admin UI. What all things are there in admin UI? And after that we can do Q&A. So first of all, before starting with RAG for using RAG functionalities, the first and foremost thing that we need to do in our ColdFusion application is that we need to whitelist our paths where these documents are kept. So there is a file in inside ColdFusion, wherever your installation is, inside that CFusion and inside lib folder, there is a path filter.json file. There we need to whitelist those paths. So here I have whitelisted all the whole drives, although that is not recommended, but this was for the testing. So I've done that. So we just whitelist the directories that we need to use here for the key document access paths. So in production, we should just be whitelisting whatever we will be using. And after once we have whitelisted, the ColdFusion server restart is required for it to take effect. Now we'll talk about RAG. So what exactly is RAG? So when we are using some LLM like ChatGPT or Claude or Gemini, so when we are giving a query to those LLMs, they are trained on huge sets of data, which they use and then they try to answer it. But what if we ask some questions to LLM, which is on which it is not trained? The documents which might be private to your organization, some specific niche that you want to question, that you want to discuss, or that you want to query using LLM. Those ideas, that training will not be there with the LLMs that are there. So that is where RAG comes in. So RAG is retrieval augmented generation. What happens? With the LLM will be answering with our data, whatever document we will be uploading to it, we will be giving it. Then there is a process that gets followed, and based on that, LLM will be answering the query that whatever you give to it using the documents that you have provided. So I'll give you a quick overview how RAG actually works. That is a very bird eye view of how it works. So when you give some documents to you have some documents, then you split it into chunks, and then the chunks are just the sentences and words, just small pieces of text, which are then further converted into vectors, which are also called embeddings. And then those vectors are stored in the vector database. Like we have databases for MySQL and all these traditional databases that we had. We used to query. Similarly, there are vector databases which store the vectors inside it, and these vectors are whatever document we give, split it into different chunks. So when we ask a question to a RAG service, the query that we give, that also gets converted into vector, and then that vector and the knowledge base that we have, there is a semantic search that happens. Whichever chunks are the closest to these queries that we have, those chunks come. Then those chunks are sent to LLM, and then using that data, LLM tries to answer whatever question we have asked. So this is a very high level view of how RAG works. So next we'll go through what we will be covering. So I have some documents which I will be using, which I have created some fictional documents, which is like which talks about what product docs we have, the pricing and integration, those support options and documents like that. Then I have created a employee handbook and some frequently asked questions. So these are the documents that I showed here. these are those documents. They are in different formats. As you can see, all these are supported. So that we will be doing. Then in the demo, we'll be asking the questions based on those documents. Then further, how we can fine tune the retrieving of the document from the knowledge base using that semantic search that I told you, how that can be further fine tuned and made better. And then we go to guardrails and regs. So just what are guardrails? Guardrails are just if there is some sensitive information that should not be displayed to the user or which should not be answered, so those are called guardrails. And then if we have a large set of document, if we have a huge number of documents, or just one document is very huge, how do we handle that and how that ingestion will happen? So when we say ingestion means just the documents conversion into vectors, embeddings, and then getting stored into the vector store. So the first part is simple reg. Simple reg is the quick start tool from ColdFusion, which requires minimal configuration. Just to if we want to create some small service and just try out things, and if we don't want to fine tune things a lot, simple reg is the really is the solution that you want to use, as it is really quick. So this is the same thing that I told you, that why reg is necessary. So the basic process of reg services, we will be ingesting the data, then we will be retrieving means the taking out the chunks, similar chunks from the DB, and then augment it. So the process where our query, whatever we sent and whatever documents we received, them getting together and going to LLM for getting answered, that is called augmented prompt. We asked a prompt, then documents came, and then the augmented prompt is what goes to LLM, and then it gets answered. So this is the code how we actually create a simple reg service, which is really fast. So this we need to first we need to create chat model, where we show what provider we will be using, what, like OpenAI is the provider here, what model we will be using. So there are multiple models under each providers. There are multiple providers that are supported in ColdFusion, and so we'll be using the model name here, and then we need an API key for LLM accessing LLM. Sorry. So, and then like Pujita showed how we create vector store. So vector store, this is how the similar way we create the vector store. So whatever demo I will be giving and whatever code that we will be, this demo code will be given out on GitHub repo. And this demo uses Milvus vector store, although any other one can also be used. So here we create vector store, and then this is how a simple reg service is created. So this is a function name, simple reg. First argument is the path to a directory or the file that we want to use in our reg service. Then the second one is chat model, whatever LLM that we will be using, that is given here. And only these two are the parameters that are required. The third one I have passed here a struct with vector store, telling that it needs to use Milvus vector store, which is this configuration hosted here, and these collection names and all that. If I don't give this struct here, and if I only pass these two parameters here, then simple reg will be using in-memory vector store, which is stored in the RAM of the system, and then it is being used. It gets used. So the only thing with in-memory is that when server gets restarted. Whatever you might have ingested in that vector store, in memory vector store, that gets wiped out. So but if we use some provider like this, it is persistent, and then we can use it anytime. So we created a RAG service here and gave it documents. We gave a chat model LLM that we want to use. Then we mentioned what vector store we want to use. Then we call ingest. Ingest is then these documents will get converted into vector embeddings, and then they will get stored in the vector store, whichever we have told. Now there are two methods that are there in simple reg. There is ask method, then there is chat method. There are these two methods. Yep. So what is the difference between ask and chat? So the way to use both of them is the exactly the same, just the method name is different. So what happens in ask is that ask method is very useful for one time queries. So if you have a knowledge base and if you just want to throw a one query at that knowledge base and get the answer and that's it, then we should be using the ask method here. But what happens with the chat method is that we can have a continuous conversation with our RAG service. So if we ask X question to that using chat, if we ask X question to RAG service, then it answers. Then the second query that we throw at it can be related to the previous one, and the RAG service will be able to answer. Although in ask that will not happen, it is a one-time query thing. We'll see in demo. Let's show you. So if suppose if we do not create a RAG service and if we just ask some question directly to LLM, then what happens? So there are documents about, like I said, pricing products and all that we'll be using. If I just ask randomly question to it, that what are the pricing plans, so LLM will not be able to answer, or either it will be giving just some hallucinating answer. So it said, I don't know the information and just the generic answer. But here is the question. Here is the demo with simple reg. Where we will be ingesting the document and we will be asking the question. So when I ingested, so the here a collection might have been created. Ask, and this data came here, whatever I gave. So as I was using in Milvus, this data got these embeddings got stored, and when I will be querying now, it will be taking out the chunks from here and then answering based on that. So now if I ask the similar question here, then the answer will be relevant. Yep. So this is the answer that we have here, which makes sense. This is according to the document that we have. So this is LLM versus a RAG service. Now we'll see ask versus chat. So the same set of documents, and so another set of documents that I have used is that HR handbook that I showed you for some ABC company that I have created. Uh, uh, this window shows the ask, whatever we will be doing, ask query. So if I ask it to list every type of leave at ABC, then we'll get an answer. So these are the it listed properly. Now if I ask to it, tell me about the third one. See, so it was not able to recall that I'm talking about this third point. It gave some other option here, other answer here. Now if I use the same documents and same queries in the chat model, chat method, the it will be able to recall the whatever it answered last. So we got a list here, and then if I ask, what about the third one? Then it can it refer to this, that the personal leave, we are talking about personal leave here. So this was about ask versus chat, and that is pretty much it in simple reg. Although some configurations are also part of simple reg. So chunking. So what is chunking exactly? If we have a long book, suppose, or some 10, let's suppose 10-page handbook, some document. So all of the full document cannot be, it is not very efficient to create a embeddings of that whole one book together and create a vector for that. As if we create a vector for that thing, it will lose its meaning, and it will not make a lot of sense, that will not be very efficient. So what, and also many embedding models have some context limits that are there for converting them into embeddings. So that is also one of the problems with large documents. So what we do is just we split it into chunks, make them create parts of them, and then we embed it, we store it in vector store, which has its own benefits. The best one is that the embedding model is able to create embeddings without any context limit exceeding. And then the other one is that if there are chunks of our documents, then similarity search is easier to search. If there are small documents, only the relevant documents are retrieved, and then they are passed to LLM, so that LLM then is able to answer properly. So in simple reg configuration itself, there are these options that we have. So in the struct where we passed vector store, we can tell what is the chunk size that we want to split the documents in, like 500 characters that we need to, if that is a 2000 20,000 character long document, that is just example. So we need to create chunks of 500. So and then there is chunk overlap. Chunk overlap is to be used because what if there is no overlap and some sentence gets cut in between and gets stored as different embeddings, different vectors, then the sorry, then that sentence will lose its meaning, and it will not be possible to retrieve that properly and use that answer. So if there is one sentence that is cut into a one chunk, then another one should start with overlapping some last of its characters, so the sentence and embeddings won't lose its meaning. Other thing is that max results, how many results are there, that how many retrieval documents are there that we want to retrieve. Then there is min score. Min score is that this is the minimum score. This is a parameter which shows that this is the minimum similarity that must be there with the documents that are retrieved. And range for this is from 0 to 1. And then there is continuum error. If something fails in loading, we should be continue with the service, or we should stop it. So that was it with the simple reg. Then there are vector stores and providers. This is Pujita covered either way, so I'll just go through the providers whatever we have. These are the LLM providers, the chat model thing that we saw. So we have OpenAI, Anthropic, Gemini, then Azure OpenAI, then Mistral and Olama. Olama is an application which helps you run these LLMs on your local system without ever getting connected to internet, not requiring that. So that is Olama. You can host any model with that. Embedding providers, whatever the embedding providers are offered by these providers, embedding models that are offered by these providers are also supported. So these are the vector stores. In memory is that it does not require any setup, but on server restart it will lose the data. And then there are these vector stores. Now we'll come to document ingestions and formats that are supported. So these are the supported formats that we have for RAG. These are the long range of formats that are supported. Almost all of the text documents that can be used are supported here. Then there are loaders, and then there is splitting. The loaders are the loaders that we can use are file system. Either we can load a single file giving the full that file path, and or we can give a directory path with pattern filtering also, that this is the directory and I need these files only with these extensions that can be used, and URLs can be used, passing the URL in the service and then loading it. Then there are splitting strategies. These splitting strategies are nothing but criterias based on which we want to split our documents. It can be a paragraph, like wherever a paragraph ends in our document, that will be one chunk. It can be a single line. Wherever a line gets uh, ended, you take that line and create embedding and store in the vector database. And like that, seven splitter types are supported in RAG. These are the splitter types. Then there are parameters, chunk size, chunk overlap, that we discussed in simple RAG. The same thing here. Now this is the big part of this is the main feature that is coming out, and this which has a lot more options, a lot more ways to fine tune, to customize whatever your RAG service wants to, however you want it to configure. It offers the advanced RAG is the part that we want to use. So we can take control on every stage, be it fine tuning, then chunking or routing query, aggregation, or content injection. There are a lot of parts to it, which I will be showing you and giving you a demos for that, helping you walk through that. So this is a short example of how a RAG service for advanced RAG is created. We will be using agent function for creating a AI service for advanced RAG. Here we give the chat model, whatever chat model that we want to use. Inside ingestion, we pass the documents that we want to ingest. Then document splitting techniques and splitter types, what we discussed, that they go here. Then vector store ingester. Inside this, we give vector store, whatever vector store we want to use. Then there comes retrieval augmenter. There inside that we have a lot of options which we will be coming to next. So first one, there is ingestion pipeline. So what okay, so what are the parts of the ingestions? We load the document. There are what document loaders we have: file, directory, then URL. Custom UDF is not supported. This will have to be we'll have to remove. Then document transformer. We have document transformer. Whatever document that we are giving before ingesting it into the vector DB, how if we want to apply some transformation to that document, which might help us in retrieving the document from knowledge base why at the time of retrieval, then their document transformer is used. In document splitter, same thing, the same document splitter that we discussed. and then in vector store ingester, what batch size we want to use, then where we want to store the chunks, and all those options come. And then there's one more thing for segment transformer, where when segments are created from that from a document, then if we want to apply some transformation on that, that is where it is used. So first we'll come to transformers. First, for these options, where we give fine tuning, which we discussed, that min score. I'll show you in the demo for advanced reg. So if we want to create the chunk size of, let's say, these are two configs that we are seeing here. First one is just the basic one, that if there's a huge chunk size that is getting used. Top k1 means that only one document will be retrieved from there. So this is very basic config, which is very naive and might mess up your queries for your rack service. Then in the other one we have tuned config. We'll see for the starter config ones. So if I ask what integrations are available, so only one chunk got retrieved from this product box dot txt, and this chunk was, so this all this comes in the metadata. Whenever we do retrieval, I'm just taking the information out from there and showing it here. So this is what got retrieved, and the score was 0.66 here. So although it worked correctly, but the configuration is not very good. If there are large number of documents and huge documents, then it might hallucinate and give incorrect answers. On the other hand, if we use some tuned config and top k, let's say I said 4, that 4 chunks should come out, then minimum score that uh, if a minimum score is less, then it means that the documents that we want to retrieve, it is not a huge factor for us that the similarity is less. So if I use minimum score less and set top k to more, then we'll be getting more documents as retrieved, but relevance might differ. So these are the tunings that you should be using in your config for getting the whatever gives you the best result. So I'll be setting here like minimum config, say 7.7, and splitter type I'll use sentence, and chunk size will be 400. I'll start with this, and then we'll see how retrieval happens and what answer we get. So as min score, I have set 0.7. So the chunks that whatever chunks were created, 0.7 seems like a high min score, where it did not work properly. So if I use a min score 0.3, I'm sure. Yeah. So we got these 4 chunks with these min score, and we got a answer out of the documents. These are the 4 documents that we got. If we change top k to something else, then those many chunks we will be getting. So these are the tune options that we have, which you can use as per your whatever gives you the best results for your reg services that you can use. Now coming next to transformers. So transformers are the options that, like I said, whenever we are giving the documents to rag service to ingest it and keep it in knowledge base. If we want to add something to those documents before getting ingested, so that that detail can be used while retrieving from the knowledge base, and that can help us. So transformers are the ways to do that. So this is one way of showing of how we use transformer here. I give it the document, and then I, in the metadata of the document, I'm just adding the time. This is just for example that this is the time, and then whatever the word count it has, I am adding it here, and then cleaning the tags and all, and then this document it gets transformed, and then it gets ingested. So when we are retrieving, if one of the factors that we want to use is that a document should have been processed at this time, so this can help us. Similarly, there are segment transformation. This is the document, this is segment, and if we whatever data we want to add here to the metadata, we can add it. I'll show you the transformers demo. For precision tuning, I'll show you a doc, the just the overview how I used it in this demo. So this is the agent that I have created. Here the chat model is given. Ingestion, we gave source, what docs that we have to use, what splitter, document splitter, splitter type we will be using, that we are setting from there. Whatever chunk size we give there, from there we will be using. Then there is chunk overlap. Then there is a vector store that we want to use, and then in retrieval augmenter we are using this. So this is just a basic agent that we created for when we were seeing this fine tuning, precision tuning option for advanced rig. Then there is transformers. I'll show you transformers. So I have given the documents to the code, and then we will be applying the transformers, and then we will be seeing what things got changed. So this is without transformers. If I give a document to a service, then this is the metadata that is there. That is default system metadata that that file has. uh, we can see it here. These are the fields and these are the values for that. But if we want to add more data to this thing, then we use transformers here. And then if I do it with transformers, then we can see the difference that there are some fields that got added. So for indicating, I'm using this flag here to say, show you that this care count, this time that we saw, like in that function, at what time it got processed, then other metadata that we are adding here. So these are all the fields that we have. So this is the difference between using transformer and not using transformer. There are a lot more options to this thing which we can use. If we see how it is being used here, so here we in that agent service itself, rag service itself, all of the things are passed the same way. Just inside this ingestion, I have given the document transformer as well, that whatever these things we need to add, and then it gets added there. Per segment transformer also it gets covered. I add the length and then this price whatever is there, and then it gets added, and then we ingest it in our vector database. So this was transformers. Now there is batching and async ingestion. So this comes this this is the option that we want to use if our documents are very large, either very large, a lot, or they are in a lot of numbers. The number of documents is a lot, so we don't want to uh, just take all of them at once, and so it does not. If we take all of them at once, then it will block us. So batching and async ingestions are the options that we can use here. So we can create we can create batches, and in those batches the ingestion will happen, so the system will not get overwhelmed, and it and this way large number of documents can get processed. And in async ingestion, suppose if the document numbers and length of the document is very large and we are ingesting, and it we know that it will take very long, but we also want to query the whatever is ingested till now, there we are using async ingestion. This is the way to use the it is just the ingest method with we call it like ingest async, which will return future to us, and then we can use it accordingly going ahead. Next, we till now we saw ingestion and the ingesting pipeline. Now we will be seeing retrieval pipeline. What are the options there? What all options are there that we have while doing the process of retrieval? So there are some components to it. Query transformer. So query transformer is is something that we can use while querying, when we are giving the query to LLM or the RAG service to answer it. So query transformer, let's suppose there is a document that we want to query which is regarding uh, HR policies, but you ask the question in a very vague format, or if it is very long, or if it is not proper. So let's suppose you want to know how many days of leaves that you are there that you want to take. So you type a prompt like you give unnecessary information, that any unnecessary information, I live here, I work in this company and all this, and then whatever other details we give, and in the end we want to ask what are the number of leaves that we have. This is just for example. So a lot of this queries part is not useful. So we would want to transform this query, making it crisp and to the point, so that the answer and retrieval are properly processed. And same way, if the query is very small, if we want to make it better, which fits into the context with our conversation that has been going on, or the documents, then there we will be using query transformer. In case for query router is the option that we want to use when there are multiple data sets that we have in multiple vector stores. And let's say there are three departments that are there: HR policies, then there is medical data set, and then there is something related to finance. So now if I ask how many days of leaves I have, instead, if we don't use query router, the system will go to all of these data sets and try to retrieve the documents from there, take it here, and then will send it to LLM. So what happens here is that if it gets some documents from all three of them, and then it sends to LLM. So when it is going to LLM, then that token, then it increases the token usage a lot, and then it might cost more than unnecessarily increase the cost. So query router is the option that we can use when we do a query. Then it gets routed to the relevant database. If HR or every database and collection will have its own description. If the query matches with that description, then the documents will be retrieved from there. They will come back, and then they'll go to LLM, and the answer will still be relevant without processing so much and costing you so much. Then there are content retrievers. The options that we have in content retrievers, the configs that we can set while retrieving the data from the knowledge base. Then there are content aggregator. If there are multiple chunks of documents that got retrieved, then they came. If we want to aggregate them in one way, If we want to modify it like that, then there is content aggregator, and then content injector is also one of the options that we have, where we can add anything to our final prompt. We will be coming to this. So these are the 5 points in content retrieval pipeline. First, we will be seeing content retriever. So this is how content retriever is set. So in content retriever, we will be giving the vector store, max results, how many top top matching most relevant chunks we want, what is the min score, and then there is this description that these are the documents uh, for like product documentation and FAQ here. Then there we can also, this is one content retriever, then there can be multiple content retrievers as well. We can create them like this. So one is this HR policy is leave expenses, then there is this product pricing integrations, these things. So these are two kinds of content retrievers. Transformers, okay. Now this is how we do how we use query routing. So we inside query router we give all of our content retrievers that we want to use in our service, and then after that we add here routing model. We give chat model. So what will happen is that whatever prompt we give, that prompt will go to LLM, and these, based on these descriptions, LLM will decide which one is the best to use for this query. Then it will come back, do the retrieval, then go to LLM, then we'll get the answer. This is how query routing works, and this is how query transformation will work like. So this everything stays the same. Then just there is this query transformation. There are what we want to use, what we want to do. Is it compressing? If the query, like I told you, the if the query is very long, we want to compress it at coming it to the point, and we want to remove the fluff, then we use it like this query transformer. We give content retrievers, and then we go ahead and ask our LLM service. So first I show you what first I show you content retriever, and then okay, the content retriever, and then we'll go to query routing. So this is loose retriever. So I have said top k, that I need these top k matching results, and the minimum score that we want is nothing like 0. We should not ideally be setting it to 0. Just for the demo, I've set it to 0, and we'll see what we got. So we got these documents which has 0.8 score till we have 0.5 also. So if we do lose retrieval, then our LLM, the service, might end up hallucinating, and it is not very good, because so many chunks got retrieved, and then they will go to LLM, then they will cost a lot, and also create the LLM might hallucinate and answer incorrectly. While on the other hand, we can set the options that I showed you. There are more options to content retrievers. We can set them here. So if I do use it like this, then we got only 3 most relevant ones, and then we got the answer. Although the answer was better here as well, relevant here as well, but the number of chunks got retrieved were not proper and not ideal. Here the answer is the same, but it won't cost a lot and won't take a lot of processing time, or uh, it won't need a lot of resources for processing. Now I'll come to query routing. So here I am on the left side, the demo that is there. Here I will be using only one content retriever, and on the right I will be using multiple content retrievers, as I showed to you here. So we'll start it. So if I ask the leave policy, it gave us the answer for the leave policy. The chunks that, although the chunks that got retrieved, they were mixed. They were mixed from everything. We have from HR, we have product documents, we have FAQ as well. So which is not ideal. Okay, so as the min score is high right now, the all of them, we can see that they got retrieved from a particular that same document. Only if the min score was low, which we can edit in our code, and then we can see, then we will get other documents as well. This is without query routing. But if I use query routing, and then if I ask it, the number of chunks that we get are these. Okay. Okay, so I don't know why there might be something wrong here. It retrieved from all three docs. I'll have to check what's wrong here. But ideally, what should be happening is maybe no, this should not be happening. I'll have to check it. But ideally, what will happen is, if we are using intelligent routing, query routing here, it will go to that retriever only, where it is supposed to find the most relevant document. It will retrieve them, give it to you, and then it will use to answer the query that we have asked. This before it gets checked in, I'll check what's wrong here. So, but the ideal, what is the behavior expected? I told it to you. The how we use it here is the same as the ones that I showed you in the slide. Inside query router of the service, we gave this routing model, and then vector stores, and then it should retrieve from a correct vector store. So this was about query routing. Then query transformer also we talked. Then there comes content aggregator and injector. So this is how we merge and aggregate the content, whatever is retrieved. So we are adding the separator here. We can use any way to aggregate these contents. So this is whatever is retrieved. So this is one content aggregator part. Coming to content injector, this is how we use content injector. So this is the code how it should be used. Wait, so this will be much more clearer when I show it to you in the demo. This is basically the way to use content injector and content aggregator. So this is aggregator. This will show you if I try to retrieve it. Okay. And then if I do the same thing here. So here, from one source, it took without aggregator, the chunks that got retrieved, they were like, these were top 5 chunks that got retrieved, which were mixed. But if we used content aggregator, we will pick the most relevant docs from all of those vector stores. This is a if all of those stores have relevant documents, we will be taking out the documents from there, uh, chunks from there, and then we will be aggregating it, and then we send it to LLM to get the answer. So this is how it helps. If we use only one single store and one retriever, then only that store will send us the documents, and then that might be incomplete information. Our answer, that is the case where our answer could have been better if we use multiple store. Here I am using two stores and then aggregating the whatever retrieval I got, then getting answers based on that retrieval. That helps us getting better answers and reliable answers to our queries. This is the role of aggregator. If I come to injector, so the default prompt that we have, so whenever we are sending the prompt to LLM after retrieving the documents from the DB, this is how we send it. It is this is the system prompt that we have. So answer the following question to the best of your ability. This is the message that we send, and then base your answer on the following information. The contents are the retrieved documents. So I sent it. What are the integrations? What all are the integrations available? We got a generic answer, decent enough answer. But if we want to use content injector, the default, the prompt that we send, we can set anything here, whatever we want to use for everything that is being sent to and being queried. So I edit this thing here, that you are a support assistant, you should answer in this template and all these things I told it, and then we'll see how it gets answered. So the way of getting the way of answering from LLM is different if we use content injector and if we don't use it. So this depends on the use case. However, you want to use the prompt, like there there this is the way to how we would set system messages in any LLMs. So if we want, we can set it here that always answer the questions in a poetic manner. So all the answers we will be getting in poetic. So there are different use cases that we can use here in our RAG system using content injector. Next thing that comes is guardrails. Guardrails are the configs that we use for blocking the responses. There are two types of guardrails: input guardrails and output guardrails. Input guardrails are used to block the query when we are sending some query which has some uh, sensitive data that should not be there, that needs blocking. That for that, input guardrails are there, and then same output guardrail. Let's suppose LLM answered something incorrect which we do not want to show, then there is output guardrails for that. So this is how guardrails are used. There we need to create a CFC file where we where we give the patterns that we want to use, that these are the patterns that should get blocked, and then we give, here I will be showing you input guardrails. These are the I give it input guardrail, and then output guardrail also I create. Let's suppose I created something and then I gave it here. This is the way to give the guardrails inside RAG system. Although this is the main part of LLM feature for in ColdFusion. So I'll just give you a quick demo for this in guardrails. So if I start without guardrails and if I tell that my credit card details are this, although it will, although yes, we got that for security reasons this is not the correct way to share things and all that. If I ask that what is my social security number, then also it will refuse. But this is because I am using OpenAI's model, which has its own guardrails set, so it is answering like that. But if you use some model through Olama, or some model which is not that, which does not have the guardrails inbuilt in them, then we will be using our own guardrails. So this is the answer for input guardrails that we have made. So I created with guardrails. Then if I tell it that my credit card number is then it got blocked. because sensitive data, there we said credit card is one of the things that should not be there. Then if I ask SSN number, then SSN number also it got blocked. So this is guardrail. These are the guardrails in reg. Same the way to use those guardrails is just the same as I showed it to you in the slides. We create a CFC, there we tell them that if you detect something like this, then we need to block it, then we send it in input guardrails, and then we use it like that. Now coming to the last and third part, document processing service. All of the things that we have talked, chunking, splitting, splitter types, transforming, all of that can be done. Till now, we were doing it inside the RAG service, where we were using the things inside the rag service, and then we were querying it. But what if we don't want to use if we don't want to create rag service at all, but we just want to process our documents, we just want to create embeddings, vectors, and splitting it, and using all these options that we have, we just want to use it like that, and we want to store it somewhere. So for this, we have document service in ColdFusion. This is how document service is created. We give documents to it. Then let's suppose we want to split it like this. We split it like this. Then we are transforming it. Then we are ingesting it, and then we just close the document service. So rag service did not get created here. We did not ask it. Neither the chat model or LLM was required. We just processed our document which was there, and we kept it in our vector DB. That vector DB, that data, ingested data, then can further be used by any other vectors rag service that we create, and giving this vector store to it. I'll show you. So left side of this demo ingests the documents using the document service option. They got ingested, they are inside that rag vector store document. Now I will create another rag service using agent. There I will not be ingesting the documents. There I will just give the vector store which it has to use for the retrieval, and I will start the rag service here. So just I ingested these documents using vector service, document service, and then I will use those embeddings inside this rag service where I have not ingested something using this service. So if I ask this pricing plans, we got a relevant answer. So it is able to retrieve the chunks from the knowledge base, and then you show it here. Then the last part of this is that is lazy load and async methods. Lazy load is that if we have a very large data set, if we have a lot of number of documents inside our data set that we want to process. So if we normally load it, and if we normally try to ingest it, it will be a huge load on the system, and that is not a proper way to process these large number of documents. So for that we have lazy load here. We we load the documents using lazy load, which returns the iterator to it, and using that iterator we use to then process those documents, so that this does not overwhelm our system whatever we are using. So the same thing is the same async methods we have: load async and then ingest async. There are multiple methods for async methods that we have in this processing in rag service and document processing that we can use. So this is how inside document service we will be using lazy load, we give a path where there are a lot of documents. We tell it a pattern that this is the pattern that we want to, these are the formats that we want to use, and then we just process it. So yeah, this is just normal load. Then if we loaded 50 documents and then they got loaded at once, although 50 documents is not that big, it if these were like, let's suppose 5,000 documents, it would have overwhelmed or more, some very huge, then it would have overwhelmed the system. Then on the other hand, if we use lazy load, the behavior is like this. It is loaded one by one, and the system is not that overwhelmed. So coming to the last part, admin UI, rag, there is one tab that we have on admin UI, rag ingestion. And then there is, in code analyzer, there is something. I'll quickly give you a overview to that. So on the admin, we have this style AI services. There we have a rag tab here. So along with rag, we have vector stores here. So in this using this AI service vector store tile, we can add the vector stores whatever we want to use. Let's suppose if I use it like test, then give provider, then click add, and then we add all the details for our vector stores here. And after adding, if it requires API key, what is the username, what are the creds, what are all these, if we, after filling out all these details here, if we submit it here, then this provider, this vector store will be available for us to use in our codes and from the UI as well. So I have shown you how to use Milvus. So this is the existing one that Pujita would have added for Milvus. She has added URL here. These are the dimensions for that collection name that we want to add, and she gave all of these details here. If embedding model, if we don't give any embedding model, then inbuilt embedding model is used, which is Ulama all mini LM, if I'm not wrong. So that is the default one that gets used, and a vector store gets configured here. Now using this vector store, we can ingest the documents in that vector store through UI as well. So I choose a vector store here. Then I choose embedding model. So embedding a model, if you add you while using vector store, we add it here. And then we just need to give a directory or a file path here or URL, and then we just run ingestion. So find out. So we just give path here. We choose these things, and then we just run ingestion. Although this is just the file path that I gave randomly, but if we give some file path, directory or URL, then we run ingestion. The ingestion runs, and then we can see the documents here in our DB, like we saw. Here we have these other advanced settings as well. What parser we want to use for our documents, what character encoding, maximum file size. There are a lot of options here. After how long it should time out, what are maximum number of retries, chunking strategies, splitter types that we saw in the presentation, chunk size, all of these options we have here. We can set it here. We give the details here, and then when we ingest it, we will be able to see it in yeah. So this ingestion process happens, and then once this gets completed, we will be able to see it in our vector DB. So this the collection got created, and the data will come here after the ingestion is completed. Yes. Some issue with vector store configuration I think something will have to be changed here, but that is how admin UI is supposed to work. So yes, thank you. That was it with for RAG. If we have any questions, we can address them.
Fantastic. Thank you, Prashant. Awesome talk, you guys. That was amazing. I'm still processing. It's a lot. It's a lot. Very, very cool. There's been no questions put in the Q&A and nothing in the chat. If anyone does have any questions, please post them now. Otherwise, you can always email us or post them on CFML Slack or on LinkedIn, wherever you'd like, and I can get it to the appropriate engineer to answer. Otherwise, I just want to thank Pujita and Prashant for their amazing talk today. Very, very cool. Super complicated stuff for folks that are not used to it, but this is the world we live in now. So yeah, this is the stuff we all need to learn. So thank you for providing that for us. It's going to be a very popular rewatched video on YouTube, I believe. So this has been recorded. It's going to be put on YouTube. In fact, I'm going to stop the recording.